Hello and welcome, I'm Tafaragadamu. My guest today, Dr. ZereSenay Alemseged, and his team of scientists have discovered the oldest evidence of human tool use ever. Today, Dr. ZereSenay says we can safely conclude that pre-humans started using stone tools 3.4 million years ago. A very warm welcome to this program, Dr. ZereSenay.
Thanks for having me.
What is that you found? We know now that you've discovered, you and your team have discovered two pieces of bones, and they were dated at 3.4 million years.
Yeah, this new find is the earliest evidence for the use of stone tools in the human lineage, and at the same time it tells us about the very first emergence of meat eating in our family. And these two key human attributes emerged over 3.4 million years ago. This evidence tells us. And at the same time, for the first time, we demonstrated that the Salam or Lucy species, known as Australopithecus afarensis, used tools and also consumed animal meat. And even though researchers were working on the sites for over 30 years, no one was able to demonstrate this, and we did it for the first time.
We'll talk about that in some detail. Give me a picture of what these bones are. There are two pieces that have been published in the journal Scientific Nature. What are these two bones?
The two bones are part of a huge collection of bones that we collected from several localities. But these two bones, one is a fragment of a rib bone from a large mammal, a buffalo or a cow-sized,
really huge,
huge animal, and then the second one is a goat-sized antelope, so a gazelle or an impala-sized antelope. The bone comes from the femur or the thigh bone, which is the upper part of your leg. And these two bones preserve evidence that our ancestors 3.4 million years ago used sharp-edged stone tools to carve meat of the bones, and also pounded, hammer-stoned the bones to extract the bone marrow.
You decided that this was the case because they left marks in the process of the
Yes, because when you use tools to cut or to remove the meat or the flesh from a bone, you inadvertently also go to the bone, and you leave traces of marks of the cut that you make on the bone, and that preserves for millions and millions of years. And there are unique criteria that help you identify those marks that were left by this very early stone tools.
What are these? I mean, why couldn't this be marks left by
like you can say by a rodent or by a crocodile, etc. Because what is exciting about what we do is that the marks that are left by say a rodent or a crocodile are very different in terms of their morphology, the way they appear, and there are scientific experimental works that can help you identify what is left because you used a stone tool as opposed to what is left when a crocodile or a rodent is basically trying to get the meat off the bone. So these are marks that clearly show that early human ancestors were using these tools to extract meat and bone marrow.
What did the tools look like? The stone tools look like? Were they handy? I mean, can members of the Australopithecus afarensis, that species, how easily could they manipulate the bones?
Well, for a long time, way over 30 or 40 years ago, a species was named Homo habilis, which means the handyman. By Louis Leakey. It meant the handyman, and they gave that species that name because they thought that was the sole species that was using and making tools. But it turns out that Australopithecus, which was thus far considered to be primitive to be using stone tools, was actually using these tools as well. So you don't need a handyman's hand trained to use and probably make tools. So
how flexible were their hands?
They were pretty flexible, actually. They had relatively longer thumbs and then relatively shorter fingers compared to the apes, for example. If you look at the chimpanzee, it will have a thumb which is way shorter, and then the fingers are longer. So they won't be able to make this pad-to-pad connection or this very precise gripping. They don't have the dexterity or the flexibility to manipulate objects that we humans have, and Australopithecus afarensis had those abilities. So it's not really a big surprise that they were able to manipulate stone tools, but no one was able to demonstrate it using the scientific data, and we did it for the first time, and that's why it's very exciting.
And you said the first time now we know that that species, members of that species, Australopithecus afarensis, were indeed meat eaters.
Yeah, because for like over 30 years, Australopithecus afarensis, the Selam and Lucy species, was named in 1978, and when it was named as a species, the picture that we had of the species was an upright walking species that would walk on the woodlands, forested environment, sometimes venturing into the open environment, but no one was able to put stone tools in their hands. But what we did here, based on this work, particularly showing that they were indeed not only using stone tools, but they were using them to carve meat of the bones and then to pound the bones to get access to the bone marrow. We put stone tools in the hands of this very important species for the first time.
Left on these two bones, can you decide how sharp or how refined those stone tools were?
Yeah, we can say that they were at least using two types of tools. Some of them were sharp-edged flakes, so relatively sharp. So you can imagine a sharp-edged flake or stone. But they were also using some blunt hammerstone to pound on the bone so they can break it open to access the bone marrow. So they will not, I don't think they were using very sophisticated stone tools like that we have, the ones we have much later in time at around 1.5 million years ago, called the Acheulean technology, for example. But they had the capacity to really make use of this relatively primitive stone tools and then really venture into a new type of environment and diet, and that's why it's really very exciting. Because
why is it exactly? I mean, what does it tell?
Yeah,
is that you're eating meat? So what does it tell?
Well, because if you really pay attention, humans are very strange in terms of diet. We are primates, and most primates don't really eat systematically meat. The chimps and the gorillas, they sometimes occasionally do eat meat, but their diet is leaves. Their diets are leaves and fruits. So when our ancestors decided to use tools and then really eat meat, they were venturing into a new type of environment and a new type of paleoecological context. And by that I mean, if you have very primitive stone tools and you are trying to access a carcass, there are other dangerous species on the landscape that have the same interest, the hyenas, the scavengers. So the competition was very high, the risk was very high. So not only were they trying to access, but by trying to access the carcasses, they were putting themselves in danger. And that pressure from the carnivores or the scavengers might have played a critical role in shaping their evolution. It makes them more networked, for example. So the emergence of stone tool and the emergence of meat eating is in a way a game-changing phenomena in our history, because once you start to use stone tool, the interaction that you have with nature is different, because you start to eat a different type of diet. The interaction you have with other species, be it herbivores or carnivores, is different, because you start to compete with them. And the interaction that you have within the group of the human ancestors themselves would be very different, because the type of networking that you need when you are facing dangerous species like the hyenas and other scavengers is very different from when you were just hiding in the more covered and wooded environment and was easy to escape from these dangerous species.
What about in our cognitive ability, the evolution of our cognitive ability?
At this time, the brain size of Australopithecus afarensis was pretty small. It was still not very different from that of a chimpanzee. But once they have started meat eating, it means that they acquire high calorie, quality food in a short time, as opposed to when they were consuming a huge amount of leaves and fruits, which you would need to acquire if you want to have enough amount of calorie to survive. So by eating small portion of meat, you can acquire what you would get from a huge amount of leaf and fruits. So, and we know that the brain is a very expensive tissue. In other words, you need a lot of energy, a lot of calories, a lot of food to process, to run your brain in a way. But we don't see brain expansion at this time. So I will not say meat eating or tool using was a trigger, the one that triggered brain expansion. But down the road, when the brain expands with the emergence of genus Homo or just after, meat eating might have played a critical role. Tool use might have played a critical role. And the type of new network system that they had when they were scavenging must have played a critical role.
Whatever you've discovered, those two bonds suggesting that early humans, our ancestors at 3.4 million years ago, were just using those tools and not manufacturing them.
At this stage, we don't know the answer. And we don't know the answer because as you go back in time, the type of stone tools, the type of evidence is going to be rare and rare. And the reason is why, because at 2.6, we have the stone tools at Gona, for example, very well manufactured assemblages.
Just like a quarry.
Yeah, like a quarry. And also at 2.5, we have from the site of Middle Awash, we have cut market bones that show also evidence for meat eating and tool use. But as you go back in time, the behavior must have progressively developed over time. So as you go back in time, it's going to be rare and rare and rare. So the stone tools are going to be almost invisible in the archaeological record, statistically speaking. So the new picture that is emerging from this discovery is that you have the assemblages of stone tools at about 2.6, but as you go back in time, those assemblages might be rarer and rarer because of the statistics that they were just starting them, so they would not accumulate them, they would experiment them, they would opportunistically use them, sporadically use them. And the same way, the type of interactions they had among themselves must have evolved through time also and become more complex at about 2.6 million years ago.
So are you suggesting that we have reached a dead end as far as stone tools use is concerned?
No, not at all.
It's also likely that you'll find older stone tools.
Yes. I think even though they are rare, you will find them because for those cut marks to be inflicted on the bones that we discovered, somebody must have used sharp edge tools. Were these stone tools made by the early hominins, or were they opportunistically picking sharp-edged tools and then using them? We don't know at this stage. So the next field season is going to be looking at the specific questions. Well, first of all, would finding those stone tools be one of your priorities? If they are there, yes. Anyway, we will do all we can to recover those stone tools. We will transform the way we were doing our survey methods from the past. So we will do a combination of approach whereby we will increase the sample size of the cut market bones. We need more of those, but at the same time trying to find the stone tools that were used to inflict these marks on the bones.
So you made your conclusions for now based on this,
based on what we have,
and you've never found any piece of stone tool or stone tool?
No, we have not.
But you think that's very important to help you determine the conclusions that you have reached today?
Well, the conclusion that we have reached today has two aspects. The age of the bones, there is no doubt. They are 3.4 million years old. The cut marks that we observed, the percussion marks that we have on the bones, we have no doubt. We traditionally used methods to determine what they are. I even exported the fossils to the US to use what is called scanning electron microscope technique to really go deep into the bones and then take very, very powerful images that give you very good images that make you very confident about the results. So we don't have a doubt about the age and the authenticity of this cut marks. But when it comes to the interpretation, and that is the difference in science, there is the fact part, the data part, and then the interpretation part. In order to make our interpretation more solid, we need more sample size. But in order to say early humans started to use 3.4 million years ago, we are pretty sure we have a very solid conclusion.
But the evidence, your critics say, is very scant.
Well, it's as scant as the discovery of Tumai, which is the earliest hominin discovered in Chad. It's only one cranium. It's as the evidence similar to the discovery of Australopithecus garhi in Ethiopia, which is one specimen. It's the same as the Oraran stuff from Kenya, which is very fragmentary. If one can show that activity existed 3.4 million years ago, that's showing you that the earliest evidence for stone tool and meat eating is there. The question is now, what is the frequency? Then it takes you to the interpretation part, and then to do that you need more information.
So as you mentioned earlier, we have evidence from 2.6 million years ago. That is the
Gona site, and then cut marks from the Middle Awash.
The Middle Awash, which is at 2.5 million years ago. What are the differences between the cut marks that you see at 2.5 million years ago and the ones that you've just discovered and announced?
Well, in our view, both of them show that they were inflicted by the stone tool activity. I have not examined personally the finds that were made in the Middle Awash, and hopefully I will be able to do it when I have the permission to do it. But it would be very exciting to compare the two bones, put them side by side, and see if you see any difference between 3.4 million years old cut mark and then 2.5 million. That would be very exciting, and that would be one of my future plans.
There is no question about the dating?
The question is the dating is one of the robust part of the study. The exact same method was used to determine the age of Salam, and this find was found only 200 meters away from the locality where Salam was found. So no one is questioning as to how old these fossils are.
But what about the layers that these fossils were found? There's layer.
The layers are 3.4 million years old.
So that's a
conclusion. We have no doubt at all about that.
Do you foresee any controversy?
Yes, the age, no controversy, and maybe the authenticity of the cut marks. By and large, I don't see any controversy as well. The controversy is going to be what the implications of this finds. So what do they mean? We have suggested what we think based on the evidence we have, but further analysis and further fieldwork is required to substantiate and make it more solid. One critic is going to be, where are the stone tools?
Yeah. Well, where are they?
Where are they? And if you can demonstrate that the bone was cut by something, by stone tool, then it does not mean that the stone tool is not out there. It means that you have not found it. Let me give you just something that might help to explain. in forensics, the scientist will do the following. He will find a person who is shot. So he will know that he was shot by a gun, and he will conclude he was shot by a gun, even though he cannot find the bullet or the gun. And as you know very well, in forensics you don't find the bullet and the guns. What you find is a wounded person. So it's the same thing in a way here. We have found the cut marks. So that means, let me go back to my analogy. So not finding the guns and the bullets in the case of the forensics does not mean that the gun is not out there. It means that you have not found it yet. The same here. We have found the cut marks. So not finding the stone tools does not mean that the stone tools are not there. They are out there. So we are very confident that we will come up with something down the road, I think.
But the fact that you pushed the evidence now available on stone tool use by 1,000,000 years than we thought before is enough to trigger the controversy.
Yeah, I mean, skeptics will always argue, and our field of paleoanthropology is very controversial field of research, which is very exciting. And actually, when we made the discovery, I was as skeptical about my own discovery as skeptics are today, before I was able to go through the whole process of the analysis, the reviews with my colleagues, obviously. And then once we showed to the scientists and was accepted by Nature as a front cover story, I was very confident. Why? Because we demonstrated, based on scientific methods, that these were indeed authentic cut marks. So the skeptics would have to wait until they see them, until they examine them, and once they have seen them, they can make their mind. But when you push something which was 2.5 million years old to 3.5 million years old, skeptics and criticism is the least you can expect, and that's part of the scientific process.
ZereSenay, thank you very much and congratulations. It was a pleasure having you on my show.
Thank you for having me, Tafara. Thanks.